this is the second systems of differential equations that the student in Burkina Faso wants me to solve for him. And in his message, he also mentioned that he could not get the answer. So let's find out why and where he's making a mistake. So to solve this type of system using the operator method, first we have to write the system of differential equation in operator form. So that is our first step. So in order for us to solve this in operator form, we can write this as 2dx plus 4dy plus x minus y equal to 3e to power t. And the second equation, dx plus dy plus 2x plus 2y is equal to e to power t. So the next step is to eliminate y in this system and solve the equation for x. So in order for us to do that, let's go ahead and in that system we can write that as 2d plus 1x plus 4d minus 1y equal to 3e to power t. And the second equation we can write it as d plus 2x plus d plus 2y is equal to e to power t. So in order for us to get rid of y, we can multiply the top equation by d plus 2 and the bottom equation by minus 4d minus 1. So if we do that, we are going to have d plus 2 multiplied by 2d plus 1x plus d plus 2 multiplied by 4d minus 1y equal to d plus 2 multiplied by 3e to power t. And the second equation will be minus 4d minus 1 multiplied by d plus 2x minus 4d minus 1 multiplied by d plus 2y is equal to minus 4d minus 1 multiplied by e to power t. So all we did, we multiplied the top equation by d plus 2 and the bottom equation by minus 4d minus 1. Now we can see that if we add these two equations, the y's will cancel out, and we can write this, we can add this as this will be 2d squared plus d plus 4d plus 2 minus 4d squared minus 8d plus d plus 2x. This is we add these two portions is equal to this plus that. So let me go ahead and simplify that a little bit more. We have 2d squared. So this is equal to the addition of the right side. 2d squared and minus 4d squared will be minus 2d squared, and 4d and d is 5d, 5d and d is 6d, 6d and minus 8d will be minus 2d, and 2 plus 2 is 4 plus 4, x is equal to the addition of those two, equal to d 3 e to power t plus 6 e to power t plus that, so that would be minus 4d e to power t and plus e to power t. So the right side, let's go ahead and differentiate that. If we differentiate this will be 3 e to power t plus 6 e to power t minus 4 e to power t plus e to power t. So we have, so we are going to have, this is equal, so we have 3 e to power t and e to power t is 4 e to power t, and minus 4 e to power t will cancel out. So the right side of the equation will be 6 e to power t. So this is equal to 6 e to power t. Now let's write this in differential form. In differential form, this will be minus 2d squared x dt squared minus 2 dx dt plus 4x is equal to 6 e to power t. Now we have a second order linear non-homogeneous differential equation that we can solve for x. The general solution for this form of equation is equal to the solution to the corresponding homogeneous portion. Homogeneous, that means equal to 0, plus the solution to the particular solution for the non-homogeneous portion. So in order for us to find xc, that means solution to the homogeneous portion, that means we're going to have minus 2 d2 squared dt squared minus 2 dt dx plus 4x is equal to 0. So let's go ahead and divide both sides of the equation by minus 2. So we are going to have d2x dt squared plus dx dt, sorry, this is dx dt, plus minus 2x is equal to 0. So we can use the auxiliary polynomial and write that as n squared plus n minus 2 equal to 0. So from here, n will be equal to, we can factor this out as n plus 2 times n minus 1 equal to 0. So n is equal to minus 2 and 1. So our xc, the solution to the non-homogeneous portion, will be c1 e to power minus 2t plus c2 e to power t. Now in order for us to solve for xp, we have to assume, we got to assume a particular solution. We got to assume that our particular solution for non-homogeneous portion is a t e to power t. This is very important step, because a lot of people might assume a solution, might assume a particular solution as a e to power t. But we already have e to power t as a solution for this differential equation. So the next to it is at e to power t. This is very important, important part. Over 90% of mistakes in this sort of equation is right here, right here. So we have to assume a particular solution at e to power t. Now, if this is our solution, then our dx over dt will be equal to a t e to power t plus a e to power t, and our second derivative will be equal to a t e to power t plus a e to power t plus a e to power t. So this will be 2a e to power t. So if we now go ahead and plug those values of x, dx dt, d2x d2 over dt squared in this equation, we are going to have, I solved this problem this morning, and I am not going to do all this, the multiplication, subtraction. I try to write the final answer. So once you plug this and multiply by -2 and simplify, you are going to have minus 6a equal to 6e to power t. So from here, we can find the value of a to be -1. So if the value of a is -1, so the solution to our non-homogeneous portion will be minus t e to power t. So this xp is minus t e to power t. So our total solution for x will be c1 e to power minus 2t plus c2 e to power t minus t e to power t. So this is the value for x. Now the next step to solve for y, we eliminate dy in this form, in step 1 form. So if we do that, if we want to do that, we can go ahead and multiply. We can go ahead and multiply this equation by minus 4. So if we do that, we are going to have 2dx plus 4dy plus x minus y equal to 3e to power t, and minus 4dx minus 4dy minus 8x minus 8y is equal to minus 4e to power t. So here, as we see, dy's are going to cancel out, and if we do all that, if we do the addition and subtraction, we are going to find y equal to, I have the answer for y, will be 1 over 9 e to power t minus 2 dx minus 7x. So this is going to be the value for, this is going to be the value for y. Now we can plug the value for x and dx. So this is our x, our dx will be dx over dt will be equal to minus 2 c1 e to power minus 2t plus c2 e to power t minus t e to power t minus e to power t. So this will be our dx. Now in this equation, we have the value for x, which is that, and dx, which is that. So if we plug those values in that equation, the answer is going to be, you have to be careful, don't make a mistake in addition and subtraction and multiplication in basics. So the answer, I did the answer and simplified it. It came up to be 1/3 minus c2 e to power t minus 1/3 c1 e to power minus 2t plus t e to power t. So this will be our y. You know, I am sure you can do that, but if you had a problem reaching here, let me know. I will redo this problem again. But you know, I don't want to spend the time for basics. I hope you liked it, and let me know if there is any problem that you want me to solve. And again, in this sort of equation, assuming the particular solution for non-homogeneous portion is very important. That's where I have seen many people making mistakes. Goodbye.